The evidence emerging so far hints, though doesn't confirm, that if the anomalous objects we're seeing are indeed extraterrestrial, and that remains a big if, they may represent an intelligence and technology beyond anything currently known on Earth. It's a provocative idea, one that's gaining quiet momentum in certain scientific circles. Now, imagine this. The most astonishing image in human history didn't originate from the James Webb Telescope, the legendary Hubble, or even the Mars roving Perseverance. Instead, it came from Voyager 1, a probe launched more than 46 years ago, now drifting more than 14 billion miles from Earth. Recently, this distant traveler transmitted an unexpected photograph of the very outer edge of our solar system. What it reveals is not only bizarre, it has stunned scientists, engineers, and even amateur astronomers across the globe. Within this single image, buried in what at first appears to be nothing but static and noise, lies something extraordinary. Thanks to sophisticated denoising algorithms trained on legacy data from the Cassini and New Horizons missions, researchers have teased out a spectacular discovery: a vast, filamentary structure glowing faintly across the frame. These luminous strands, delicate tendrils of what looks like cosmic plasma, seem to map magnetic field lines or streams of interstellar dust as they intrude into our sun's fading sphere of influence. This isn't a second pale blue dot. It's something entirely unfamiliar. The photograph, captured as Voyager 1 transitioned through the helipause, the threshold where solar wind yields to interstellar space, is triggering a flurry of hypotheses. More compelling still, none of these features were observed when Voyager last captured this region in 2012. The implications are immense. Periodic plasma wave spikes and surges in cosmic ray data correspond directly to the brightness variations in the image, suggesting we're witnessing dynamic interactions, not a static view, at the crossroads of two star systems. NASA's Jet Propulsion Laboratory quietly released this revelation in March 2025. It came from a series of ultra-long exposures, each up to 4 hours long, stitched together using newly developed software. Though Voyager's imaging systems were considered obsolete and largely dormant, a software resurrection enabled one final visual shot before the spacecraft drifts beyond our reach. And that image has opened a door no one expected. 3 primary interpretations are dominating the early scientific discourse. The first posits that the luminous strands are plasma filaments, a cosmic braid formed by the interaction between the sun's magnetic field and the interstellar magnetic field. Dr. Leila Marino, a plasma physicist at the University of Chicago, supports this idea, suggesting Voyager is slicing through these magnetic ropes as they twist and spiral. A second theory, proposed by Dr. Caspar Vogel's team at Cornell, focuses on interactions between interstellar dust and solar wind. These micron-sized particles become electrically charged as they cross the heliospheric boundary, lighting up subtly when colliding with solar particles, a glow that only prolonged exposure times can capture. But it's the third hypothesis that's the most radical. Dr. Amara Oae, a theoretical astrophysicist from Ghana, raises the possibility that Voyager's camera may have captured indirect evidence of dark matter. Specifically, she speculates that axion-like particles could be converting into photons in the presence of the helipause magnetic fields, creating faint visible patterns that might represent one of the first visual footprints of dark matter interacting with baryonic matter. As speculative as these interpretations may be, they're rooted in real physics and are already making their way into respected journals like Nature Astronomy and Physical Review letters. The excitement is not unwarranted. But the story doesn't end there. In fact, it's only becoming more surreal. Digging further into the pixel data, analysts at JPL detected a subtle, repeating hexagonal pattern woven into the glowing filaments, an enigmatic honeycomb embedded in the chaos. What's startling is its precision. Such hexagonal symmetry is famously observed in Saturn's atmospheric jet streams, but nothing like this has ever been predicted or recorded at the solar system's edge. Even more puzzling, the orientation of these hexagons aligns with Voyager's spin axis, rather than with any known cosmic magnetic field, raising the possibility that we're either witnessing a camera artifact or something genuinely new. Magnetic reconnection zones forming stable plasma geometries in deep space. And then it escalates. ESA's imaging specialists, some of the most experienced in low-light data reconstruction, joined the effort. Using quantum-assisted enhancement techniques honed during their work with New Horizons, they unearthed a second filament. Fainter and broader, it was angled exactly 60 degrees from the first. After multiple validation passes, this second structure was confirmed to be real, not artifact. Overlaying the two filaments onto a model of Voyager's field of view, researchers discovered a geometric symmetry that made jaws drop. 12 radial lines emerged, forming a pattern resembling the spokes of a wheel, symmetrical, regular, and layered like musical harmonics. The precision of it all, the spacing, the angles, the ratios, was too perfect to dismiss as coincidence. This cosmic clock model, as it's being dubbed, hints at large-scale oscillations or resonances in the plasma fabric of space. ESA physicists propose that what Voyager recorded could be the result of magneto-hydrodynamic resonance, a ringing at the edge of the solar system, like a vast celestial bell reverberating at the intersection of two domains. The implications are stunning. None of our current heliospheric models, no Parker spiral, no heliosheath simulations, predicted such structure. It forces us to reconsider the very fabric of our solar system's boundary. Could it be that our star's influence doesn't just end, but modulates, pulses, sings? And that's not even the furthest edge of speculation. With conventional physics struggling to keep pace, wilder ideas are beginning to surface. A fringe but increasingly vocal group suggests we may be looking at evidence of artificial structures, some kind of energy harvesting array, constructed by an advanced intelligence, shepherding magnetic fields across interstellar boundaries. There's no direct evidence for this, of course, but the persistence of the hexagonal motifs and their spatial coherence across multiple exposures has ignited heated debate across online forums and even private research groups. Others float quantum vacuum resonance as an explanation. Under this model, vacuum fluctuations become visible under extreme electromagnetic conditions, like those potentially present at the helipause, creating interference patterns in real space. These hexagons could be nodal features in that fabric. If so, Voyager may first have accidentally revealed a macroscopic quantum effect never before observed. Still, others lean into the simulation hypothesis. Philosopher-physicist Dr. Nguyen Tran poses the possibility that this is a rendering artifact, an edge effect glitch in a universe that might be programmed. There's no proof for such a view, of course, but it illustrates just how alien the data feels, even to seasoned experts. Yet the most remarkable thing may be what this moment represents. A renewed sense of wonder. Not from something new and shiny, but from a spacecraft older than most of us. Voyager 1, with less memory than a calculator and less power than a light bulb, is delivering humanity's most enigmatic view of where our solar system ends and the galaxy begins. This isn't merely an anomaly, it's a challenge. A quiet defiance of everything we thought we knew about the boundary between our sun and the galactic frontier. Voyager 1's newly revealed image doesn't just add data. It redefines the very landscape we've been imagining for decades. For the scientists at NASA, JPL, and ESA, it's not just a photograph. It's a map, a mystery, and a message all rolled into one. And the message is layered, subtle yet unignorable. The symmetry of the wheel and spoke configuration uncovered by ESA's quantum image team is so precise that even skeptics are being forced to reevaluate the assumptions underlying heliophysical models. The entire image field appears to pulse with a kind of structured resonance. Some physicists have compared it to a Lysage's figure writ across light years, or a standing wave forming at the intersection of cosmic forces. What could generate such a pattern? One theory gaining traction is that the termination shock, the region where the solar wind abruptly slows, may be less of a blunt collision and more of a boundary membrane, one capable of oscillating. Driven by fluctuating particle pressure and interstellar turbulence, this membrane could vibrate like the surface of a drum. And just like harmonics on a stringed instrument, those vibrations could etch repeating shapes, hexagons, spokes, lattices, into the surrounding plasma. Even more astonishing is how this matches data coming in from other instruments. Voyager's cosmic ray sensors and magnetometers, still functioning after all these years, show spikes and drops in exact synchrony with the visual patterns. It's as if the spacecraft isn't just seeing something, it's feeling it too. Not metaphorically, but physically, measuring it, recording it, and transmitting it back to us across billions of miles. Now pause and think about the scale. This isn't a phenomenon confined to a few dozen kilometers. The structures appear to span tens, maybe hundreds of millions of kilometers. They stretch and arc across the heliopause, forming a kind of border architecture far more complex than anyone imagined. No longer is the edge of our solar system a vague blur or fading gradient. It's a structured region, active and resonant, alive with hidden forces and patterns. To planetary scientists and heliophysicists, this is more than an exciting anomaly, it's a turning point. For decades, we've treated the heliosphere as a sort of cosmic cocoon, a bubble inflated by the sun's wind and protected by its magnetic field. But Voyager's image suggests it may be more like a membrane, a semi-permeable, responsive boundary where cosmic signals pass, bend, echo, and interfere. Which begs the question, is our solar system unique in this? Or do all stars possess such fringes, complex magnetic boundaries that filter and frame the transition into galactic space? Are we glimpsing a universal phenomenon, previously invisible only because our instruments weren't sensitive enough or our imaginations not bold enough? And if this pattern, these filaments, hexagons, spokes, isn't a one-off, could it be used as a diagnostic tool? A way to understand stellar boundaries elsewhere? Could next-generation telescopes detect similar structures around other stars, using polarization maps, radio emissions, or indirect dust tracers? Then there's the question of meaning. Not in the pseudoscientific sense, but in the deeply physical one. Nature encodes meaning in structure. Whether in the fractals of a fern, the spiral of a galaxy, or the oscillation of a wave function, form reflects function, reflects force. These structures at the solar system's edge may be more than decoration. They may be the fingerprints of laws we haven't yet written down. Information is the currency of the cosmos. And Voyager 1, that ancient emissary, has just made a priceless deposit. Consider that for nearly 5 decades, this probe has been sailing away from home, gradually losing speed, dimming its power, and falling silent one subsystem at a time. And yet, thanks to a handful of software upgrades, an idea from an engineer, and the patient work of ground-based analysts, it has now delivered a discovery that could rewrite how we understand not just the solar system but space itself. The resonance of this event is already echoing through scientific communities. ESA and NASA have both convened special symposia. Papers are being rushed through preprint servers. Telescopes are being retasked. Even mission planners, those thinking a decade ahead, are talking about how to follow up on Voyager's find, possibly with a probe built not to explore planets, but to dive headfirst into the mysterious magnetic surf of the heliopause. And the public? They're beginning to feel that familiar tug again, that whisper from the stars, that sense that the universe is bigger, weirder, and more beautiful than our textbooks ever dared admit. Social media is awash in theories, animations, thought experiments. Art is being made. Music is being composed. Somewhere, a child is drawing hexagons on notebook paper and wondering if they mean something more. Because that's what this is really about. Not just science. Not just discovery. But wonder. A return to the awe that launched the space age in the first place. We've sent robots to Mars, mapped distant exoplanets, and even touched the sun's outer layers. But this is something else. A message from the edge. A glimpse at the frame around our cosmic window. And maybe, just maybe, a first look at the quiet code that underpins it. With each new analysis, Voyager 1's image is revealing layers. Like a slow unwrapping of a message written not in language, but in light and field. The presence of ordered structures at such a distant and chaotic boundary pushes the very edge of known plasma physics. These aren't anomalies in the traditional sense, they're patterns. And patterns imply process. JPL researchers are now running simulations backward, testing whether known solar and interstellar magnetic interactions could under any conditions produce what's seen in the image. Early results suggest no existing model can replicate the symmetry observed. Even with complex magnetohydrodynamic turbulence factored in, the organized geometry, the radial spokes, the nested filaments, the hexagonal repetition, refuses to resolve into noise. So where does that leave us? For theorists, it's a playground. Ideas once whispered on the margins of acceptable discourse are suddenly getting airtime. Could there be standing wave modes in the interstellar medium that self-organize over astronomical distances? Could interactions with as yet undiscovered particles, perhaps remnants from the early universe, be subtly shaping these structures as solar wind and galactic matter collide? There are even whispers about topology, about the geometry of space itself bending or folding in ways that aren't apparent from earthbound instruments. Some have suggested that Voyager 1's unique vantage point, its location beyond the solar wind's reach, is allowing us to peer into an edge effect, a place where dimensional structures or exotic fields converge into visible consequence. Meanwhile, ESA's quantum-assisted imaging team is continuing to refine their model. Their latest version of the wheel-and-spoke overlay is now being compared against datasets from the IBEX, Interstellar Boundary Explorer mission, and even preliminary data from the Interstellar Mapping and Acceleration Probe, IMAP, set to launch soon. What if multiple spacecraft across different epochs have been grazing the edges of this pattern all along, and only now, with new data processing techniques, are we finally able to assemble the full mosaic? Ground-based observatories are now tuning their instruments to the precise orientation of Voyager's field of view. Some are looking for polarized radiation that might correspond to the observed filaments. Others are scanning for anomalous emissions at radio and submillimeter wavelengths that could hint at the mechanics behind the glow. Across the globe, a quiet sense of anticipation is building, not of answers, but of potential. For the first time in decades, the heliopause isn't just an abstract boundary. It's a real, visualizable place. And not just visualizable, measurable, dynamic, and filled with structure. Think of the implications for future missions. If these formations are stable, or at least semi-stable, could probes be designed to orbit them? Could the boundary itself become a platform for scientific instrumentation? A kind of deep space reef, where magnetic, particle, and plasma phenomena can be continuously studied? There are murmurs, even at the early design levels, of missions not merely to observe but to embed, to place magnetometer arrays or plasma probes directly into the filament zones, to ride the current, so to speak. The idea seems outrageous, but so did interstellar travel in 1977, and Voyager proved that even low-power spacecraft, when aimed properly and backed by decades of persistence, can yield revolutions. Meanwhile, Voyager itself continues to transmit. Its signal is faint, its power budget minimal, its systems aging, but it is still alive. Every byte it sends now is scrutinized like a relic, a digital whisper from a machine that, in some ways, is more distant than any other human creation, and yet suddenly more relevant than ever. The strange patterns, hexagons, filaments, spokes, aren't just visual oddities. They may be the outlines of a cosmic interface, a transition membrane between local physics and galactic physics. For researchers in fields as varied as string theory, fluid dynamics, particle cosmology, and high-energy astrophysics, this is a tantalizing opportunity. What happens at the edge may illuminate what happens in the heart of stars, in the collapse of black holes, or even in the early seconds of the Big Bang. And so the image is studied again and again. Each reprocessed frame, each pass through new denoising models, reveals another ghost of structure, another line, another curve, another potential piece of a geometry we have yet to name. The data is sparse, but it is speaking. Quietly, persistently, urgently. And in listening, truly listening, we may be witnessing the birth of a new kind of astronomy. One that doesn't just look outward, but inward toward the membranes that define where one space ends and another begins. One that studies not the stars themselves, but the spaces between them and the mysterious scaffolding that might bind them together. As the data continues to flow from the most distant machine humanity has ever built, a collective realization is dawning. Not just among scientists, but among anyone who dares to lift their gaze skyward. We are only beginning to understand where we are. The structures captured in that grainy, denoised frame are not merely academic curiosities. They are signs. Signs that the cosmos does not fade gently into uniformity, but instead blooms, even at its edges, with form, rhythm, and perhaps meaning. The implications ripple outward like the very plasma waves Voyager detected. The discovery forces a revision of heliospheric models. It compels cross-disciplinary collaboration between astrophysicists, quantum theorists, plasma engineers, and philosophers of science. It redefines the heliopause not as a passive boundary, but as an active frontier. A liminal region where energy exchanges, fields tangle, and structures self-assemble across incomprehensible scales. But there is also something deeper here, something less about data and more about us. About what it means to send a fragile craft into the abyss with nothing but a golden record, a prayer of mathematics, and the audacity to believe it could still matter nearly 50 years later. Voyager 1's latest transmission is more than a mystery. It's a mirror. It reflects the resilience of human curiosity, the power of long patience, and the astonishing fact that sometimes, even in the most remote silence, the universe speaks back. And when it does, it doesn't whisper about closure. It invites. It opens a door. Because the story of exploration isn't linear. It spirals. It returns. It deepens. And with this latest glimpse, this strange, luminous lattice at the edge of everything, we are reminded that the universe is not just out there. It is unfolding. And we, still listening, still watching, are part of that unfolding too. Voyager 1, against every expectation, has made contact, not with alien life, but with a structure so alien in beauty and scale that it forces us to think again. About our models, about our place, about what lies beyond the next silence. The spacecraft drifts on. And now, so do we. We have seen the edge. And it is alive.